side. Now this is a moving sheet of ice, and as it moves it does leave its mark on the landscape. One of these landmarks that we can see will be coming up on the right hand side, directly next to the parking lot, and behind that blue staircase in front of that forest. You'll see there's a long large pile of debris and rocks. That is called the terminal moraine, and that marks the furthest advance of the Athabasca Glacier in recent history. So the glacier bulldozed all those rocks there back in 1843, and since then the glacier has been procedurally receding up the valley. Now moraines are just a fancy word for these piles of debris left behind by the glacier. So on the right hand side we can see more of these moraines that are directly in the path of the glacier. So these ones are called push moraines and recessional moraines. So every winter time when more snow and ice forms on the glacier gets heavier, and it's gravity that pulls that sheet of ice down the valley. And as it does so, it rips out chunks of rock from the back of that mountain, and those rocks get caught in the ice and they get crushed to smaller and smaller pieces underneath the glacier's immense weight and pressure. So the glacier acts like sandpaper at the eroding away the bottom of the valley gradually over time, making it deeper and deeper. So as that glacier advances during the winter time, all the rocks that are caught in front of the glacier get bulldozed forward, creating push moraines. And during the summertime, when the glacier melts away, those rocks that are trapped in the ice just get dumped where they lie, creating recessional moraines. And geologists use these push moraines and recessional moraines to estimate the movements of the glacier throughout history. Now if we look to the opposite side of the valley, on our right hand side, we can see another moraine. Right up against the side of that mountain in front of that forest is the lateral moraine. So that was pushed up against the side of the glacier when it filled this valley. And the height of that lateral moraine marks the minimum height that the glacier once reached. So it was pretty huge. Also, you may have noticed that there are no trees, if any vegetation, directly in front of the path of the glacier. That is because the glacier has stripped the soil of most of its nutrients, making it hard for vegetation to grow there. Contrary to that, on our left hand side, this forest has been able to grow, and this is made up of mainly subalpine fir trees. You may notice a funny, strange feature about these trees, that they've got branches on one side of them, but not on the other. That is because we get very strong katabatic winds here. Now these winds are generated by the Cloumbia ice field and the glacier. All that ice pulls the air, making it dense and heavy, so that air comes rushing down the valley, picking up sand and debris, and it acts like a sandblaster on those trees, making it very hard for them to grow in that direction. So we refer to these trees as flag trees, because much like flags, they point in the direction which the wind has blown.